Lesson 2.4 is limits to positive or negative infinity. So basically saying as x goes to the right, what is the y values doing? No longer can we use an answer of does not exist. You have to have some kind of numerical value, or if it does not exist, actually it's a slant asymptote, but it means that it's either going up forever, so we would say positive infinity, or it would go down forever, go to negative infinity. So we have to be a little more specific. This is a very abstract concept on some of these because you're plugging in this abstract value of infinity, which is a really big value. You'll see. So if you have a polynomial, remember poly just means multiple terms, so there's no denominator or anything like that. Really all you need to know is the biggest exponent term. So out of all those, x to the fifth is the highest power. That'll actually allow me to know how this function is going to look, just generically, but the end behavior specifically. So we look at the power, which is x to the fifth, that's odd. And an odd function, one end goes up, one end goes down. To figure out which one is which, you look at the leading coefficient. So since that is negative, that means that the right side goes down. That means the left side must have gone up. So again, odd power means one end up, one end down. Negative meaning the right side is going down. If it would have been a positive in front, it would have been switched, where the right end went up and the left end went down. So now it's simply asking us, as x is getting bigger, what is y doing? It's decreasing. It's going down forever, so that's negative infinity. So that would be the fastest way to deal with the polynomials. Number 2 is another one. Look for the highest term with the term with the highest exponent. Negative x to the fourth is all we're worried about. This is even, so that means that both ends are either up or down. Since this is a negative, that means that both ends are down. So again, I don't care what's happening in the middle. I care about, specifically in this one, what is x doing, or what is y doing as x goes to negative infinity. So as x goes this way, y is going down to negative infinity. Okay, then we go on to rational functions. These are the ones that have fractions. We follow the rules of rational functions. Remember, if it was top heavy, bottom heavy, or if the exponents matched, that meant that it was just the coefficients got divided. Those are the rules of finding horizontal asymptotes of rational functions. We're doing the same thing. So all I'm going to do is circle what is the highest on the numerator. So the one that matters most is the x to the fifth over the 3x squared. So I'm going to circle those. I'm going to write it again. Okay, and then I'm going to plug in infinity instead of x. So this is where I say it gets kind of abstract. Infinity just means a big number. 10, 100, 1,000, a million. If I take a million to the fifth power, so times itself 5 times, that's huge. Oh, I put 5 here. Sorry, that's a 2. That's huge. That's going to really outweigh taking a number squared. That will still be big, but it's definitely bigger on the top. Okay, so then that usually meant if it was top heavy, I would say does not exist. Well, that's not an option because actually it's either going up to infinity or down to negative infinity. So to figure out which is which, you have to think if I have a big number to the fifth power, that's positive, but a positive times a negative is a negative. So it's kind of an abstract way of seeing it, but it's a negative 5 times something really, really big. So that makes a negative infinity. So it just goes back to your rules of multiplying a negative times a positive ends up in a negative. All right, number 4. Again, the square roots are tricky because you have to actually plug in your negative infinity before you square root it. So the higher exponent is this. So I'm going to keep the square root of 9x to the 6th, since it outweighs the other, over the negative 3x cubed. Okay, I'm going to plug in negative infinity. And think about what happens here. So this is a negative big number, like negative 100, negative 1,000. If I take a negative to the 6th power, that becomes positive times 9 is positive. So I know that this should become a positive. So really I'm square rooting 9, which is 3, I guess I should write it like this. 9 times infinity to the 6 becomes square root of 9 is 3 infinity. And then 6 divided by the index of 2 is cubed. Okay, so all I basically did is simplified this, but I now know that it's positive because of taking it to the 6th power. And then on the bottom, having a negative number to the 3rd, that's odds, that'll be negative, times a negative becomes a positive 3 infinity to the 3rd. So now think of these as being x's. They match because they're both to the 3rd, and I have to divide the leading coefficients, which gets me 1. So as x goes to negative infinity, my function is coming to an asymptote at 1. All right, then we have exponentials. Exponentials is where x is the exponent. So thinking about e, remember that e is approximately 2.7. Okay, so it's a number like pi. I am still going to follow my same rules that I've used above. So on this one, that's a rational function since it's a fraction. I got to figure out what is the highest or going to grow the fastest on top. That would be my 2x squared. Okay, and then I'm going to plug in negative infinity there. On the bottom, we've talked about how exponents grow faster than powers. But in this case, we need to think about something. If I were to have, I'm not going to worry about the negative in front of the e to the negative infinity. So then let's pick a number like e to the, make it negative 100. If I'm going to put that on a calculator, I want you to see what it gets. It's this number times 10 to the negative 44th power. So that means this decimal is actually to the left 44 places. So there'd be 0.0000043 of them and then the 3. That is so small, that's essentially 0. Because if you remember, when I take a number, say like 2, to a negative power, let's say negative 2, that actually flips it and becomes 1 over 2 squared, 1/4, or 0.25. So when I take a base to a really negative power, I essentially come down to 0. So that's what that equals. So in this case, this actually is not going to help me. That's 0. Another way to think of it is when I have e to the x and I graph that, that's basically 2 to the x power. That's my poster up on my wall. Looks like this. As I go to negative infinity for my x's, I come down to 0. As I go to positive infinity, I go up to infinity. So I put these on here to kind of help you remember that when e is to a negative big power, that essentially is 0 and you don't want to use it. So actually I'm going to use the 6x squared and I'm going to plug in my negative infinity. Okay, negative number squared becomes positive and a negative number squared becomes positive. These match, so they cancel. 2 6 would reduce down to 1/3. So I have a horizontal asymptote going to 1/3. All right, number 9, I have multiplication here. When I have multiplication, I have to actually do all of it. So I'm going to have 6 minus 4 times infinity times e to the negative infinity gets plugged in. So again, what did we just say this was? When I have a number to a negative high power, that really is just a 0. Well, 0 times anything would just be 0. And then the last one, when I have addition here, I have to go ahead and do the same thing as well. So it's 3 plus 3e to the 1 over infinity. Let's think about what's happening here. E to the 1 over, let's say, 100th power. What's that going to get? Oh, not S. Is 1. Let's try 1 over 1,000 is 1. Why is it getting that? Because 1 over 100 is 1/100th. 1 over 1,000 is 1,000th. 1 over 10,000 is 10,000th. this basically becomes 0. 1 divided by a really big number, which is what's happening here, is 0. So we actually have 3 plus 3e to the 0 power. E to the 0 power is 1. Anything to the 0 power is 1. So we actually have 3 plus 3 times 1. But that's why we were getting 1 out of this. And then that would be 3 plus 3, which is 6. So things you need to be aware of is that with e to a negative infinity, that is essentially 0. So you will not use it in a rational function. You'll use the next highest term. And then when I have 1 over infinity, that is 0. E to the 0 power becomes 1, which I put over here.